University, specializing in visualization tools and storytelling within the data analytics department. She is also working as an AI trainer for numerous companies and educational institutions. She has authored a book by the name Python Programming for Students, published by BPB Publications in January 2024. She is certified in Big Data, Hadoop, and Spark development and has achieved UGC NET in Computer Science. A dedicated faculty, a dedicated trainer who is an empowering individual with the knowledge and skills she is leveraging in every field. We welcome you, Ms. Nidhi, to the Faculty Development Program.
Thank you so much, ma'am. A very good morning to all of you. Thank you, Sonia ma'am, for giving such a nice introduction of mine. Thank you so much. So I think I can take over from here now.
Yes, ma'am, you can take over from here now.
Yes,
The
thank you
stage
so
is
much.
all yours.
Thank you so much. Thank you, ma'am. Okay, guys, I hope we are all having a brilliant morning, right? And we are going to start with this day with a glimpse of how natural language processing is being used in artificial intelligence and how you can use it for research and development purposes, like in higher education. For the people who are actually working in these domains, they know the importance of this field, natural language processing, right? So we are going to start with that particular topic today, and in the later half of the day we'll be covering large language models, which is again an extension of natural language processing. And we are going to see as many projects as we can, because I have brought for you different projects including speech to text, text to speech, and GPT-2 models, through which we are also going to scrap a website, and we are going to generate new text out of it. And apart from it, I also have some small applications regarding text processing, text generation, and so on. So this session is going to be totally a hands-on session, right? So before I actually start with the session, I just want to confirm that you all might have installed Jupyter Notebook in your systems. Just give me a quick check, everybody. You can just write down on your chat box, like, are you, have all of you installed Jupyter Notebook and Python in your systems? Just give me a quick check. Sonia ma'am, I guess everybody can write in the chat box. They have access to this.
Yes, ma'am. Yes, ma'am.
Yes.
We have
Okay.
access.
Yes. Thank you, Dr. Madhvi. Thank you so much for confirming. Rest of you guys, please just confirm me quickly so that we can do it. We can start working. Plus, one thing more, even if you don't have, you have not installed, what I'll do, I'm just sending you a link. You can just go to that link. Okay. I just show you my screen. Before I actually start, I just want you all to be on the same page by installing this complete software that we require, right? Just hold on. So guys, I think my screen is visible to you all.
No, ma'am, not your screen visible. We can, it's
Because
your
I can
complete
see this
screen being visible. Complete screen is being visible.
complete screen is visible.
Yes.
Okay. Yes. So I think now this Jupyter.org
Yes,
is
yes,
visible.
yes.
Yes. Okay. Fine. So this is visible to everybody. So what I'm going to do, I'm just going to send you the link, right? In the chat box, I have sent the link for Jupyter Notebook, right? So all of you, what you can do is you can just go to this link, and here you can see, here we have installed Jupyter Lab, right? So you can quickly install Jupyter Lab from here. And along with this, let me also give you python.org if you don't have installed python.org. So this is python.org. From here, you can download the latest version of Python for Windows, where we have Python 3.12.4. This is the latest version, right? So I'm going to send you the link for this particular site also. Okay. So all of you might have got these two links, right? Yes. So please quickly install Jupyter Notebook and quickly install Python also. So we are going to have a complete hands-on session on NLP. We will start with small basics. We'll talk about NLP, NLU, NLG, tokenization, lemmatization, stemming, and all other, corpus creation, fundamentals of natural language processing. And then slowly, as the day progresses, we are going to see projects. The two major projects that I have got for you is one in which we are going to convert speech to text, text to speech back, and second is by scrapping a news, say any news website. I'll scrap in front of you. We are going to scrap from it by using a simple API. We are going to scrap it, and finally, we are going to create text out of it. We are going to, the machine is going to learn from that text, and then we are going to generate a sample text out of it. Okay, so this is going to be a very big project. We'll see how much we can do. As per the plan, we will be able to do. So let's see. Okay, so just give me a check, guys. Have you installed it? Just give me a quick check. Are you all done with the installation part? Because these are very two small software, so I don't think they are going to take much time. Just give me a quick check. Okay, so please take 2 minutes to quickly install it. In the meantime, what you can do is, in the meantime, you can just, keep on installing it. And I think we can start with the conceptual part, right? Okay. Okay, Sonia ma'am, can you give me a check? Like my screen is visible and the presentation is also visible.
Yes, ma'am, it's visible. Both the things
Okay.
are.
Thank you. And it is moving also, right?
Can you please move to the next slide?
Yes, I am. Like,
Yes.
are we able to move it?
Yes.
Okay. Okay. Thank you. Thank you for the check. Okay, guys, so I welcome you all to this conceptual session of natural language processing. Okay, so guys, artificial intelligence in its advent has different aspects, because artificial intelligence is not only about creating robots and moving hardwares, but it is also linked to different domains, whether it is, in business, whether it is medical sciences, whether it is pharma sciences, whether it is astronomical scientists, whether you name the field, and AI is going to be related to that field, because artificial intelligence is not alone. It is related to other domains through, different subject areas. Like artificial intelligence in its umbrella term has machine learning also, deep learning also, computer vision also, human computer interaction also, and natural language processing, deep learning, and nowadays the term which is very important is generative AI, which is also under AI. Okay, so AI is not a single term. It contains within itself a very huge number of terms, which are nowadays all under AI, artificial intelligence. So one such big domain that we are going to discuss today is about natural language processing. Now this phrase is very important, guys. Just understand this phrase first of all. When I say natural, what is natural? Natural is nothing except human beings and the nature around us, right? So when I say natural, it directly means we are talking about human beings. Okay, and language of human beings is what we speak, because our speech is the natural language of, communication. Along with it, the text that we write is also the language for communication. In technical terms, in computer science, when we talk like how we communicate, there are just two mediums. Okay, one is either we are writing something and then we are communicating with others, or we are speaking something and we are communicating with others. Then that means it is either through the written text or through the language that we are speaking. Okay. So these two are the different medias through which we can actually communicate with each other. Now, when I talk about natural language processing, what does that mean? Now, understand this thing that computer system is a complete mathematical model. It is electric appliance. It is a kind of an electric gadget that can only understand power on and off. That means it can only understand the existence or non-existence of bits 0 1. That means it can only understand the bytes, that is a collection of bits. So it cannot understand what we are speaking directly. It cannot understand what we are writing directly. Everything has to be converted into bits and bytes. So normally our system, whenever it is processing something, it either has a compiler or an interpreter through which it is directly converting the high level language into the low level language and then executing something and doing something. This has been the strategy of working from past many years, right? When we are developing softwares, when we are developing applications, this has been our strategy. The point is how directly we can talk with computer system, or how directly computer system can talk to me. It can speak something that I can hear. It can write something that is generating, that the system is generating itself. I can read it. So computer here wants to communicate with us through those two media. That is either through written text or through speech, through vocal speech, right? So the area of artificial intelligence which enables humans and computers to interact with each other without touching the screen, without doing any other thing, without physical touch with the screen, only with the help of speech and text. This domain, which is helping system and humans to interact with each other, is known as natural language processing. And in simple language, what I say, natural language processing means to process human language to be understood by computer system, and vice versa, to process computer language to be understood by the humans. Okay, so the entire processing system of human language and computer systems language interaction, the communication between both of them, is natural language processing, right? Okay, so I hope the base is clear that what we are going to discuss. We are going to discuss the interaction, the communication between computer system and human beings, and how those words that we speak are used by computer system to analyze something, to generate something new, to to process it and make something different out of it. Okay, that is what NLP will contain. Now, this is a brief about me. Already Sonia ma'am has introduced me to all of you. So I have 11 years of experience and I'm into this field of teaching and training. And my specialization includes Python, data science, machine learning, AI, NLP, deep learning, and all the domains which are related to Python and data analytics, right? And apart from this, I also take trainings in business analytics, including Tableau, Power BI, business intelligence tools, and so on. Okay, so I hope you are going to enjoy this journey of learning natural language processing with me. So let's start with it. So this is going to be our, entire, the itinerary for this day, which is going to be the introduction to NLP, its components, the components of NLP, how we are going to set the NLP pipeline, what are the basic parts of NLP pipeline, then what are the basics of text processing, and we are going to see side by side different demonstrations of each and every component that we are going to learn today. Okay, fine. So guys, now formally, very formally, what is natural language processing? See, as I told you, communication is the most vital feature of life and society. Without communication, we are nothing, because इंसान social animal है, ये तो हम जानते हैं भाई, बात किए बिना हम रह नहीं सकते, ठीक है, ये तो this is far natural. Every human being needs somebody to talk, either to write something or to talk to somebody. We need communication. So the language is defined as a technique or system of communication through speech, reading, writing. Okay, so in the advanced era, AI से बात करते, जब हम AI में काम करते हैं, so the main question that arises, the main question that pops up is it possible for human beings to communicate with computers in our natural language? The only thing is that we can talk to other human beings, but can't, is it possible that we can talk to our computer system? Yes, it is possible. Like nowadays, just see simple applications. If you open your Google Assistant, you are just talking to it. You are saying, okay, Google, navigate me to so and so place. Okay, so suppose I am in Noida, so I just want to, I just want Google to assist me and navigate the way reaching Janakpuri. Okay, so it is going to, open the Google Maps. It is going to set the source and destination, my current place and the place where I want to reach, and it is going to set the GPS for me. So, I have just spoken a single sentence and it has interpreted it, it has applied it and opened the required application. So that is the, the crux, or the essence of natural language processing. Whether you use Google Assistant, you use Siri at your home, or you use Alexa at your home, Echo Dot at your home, or simply you have any voice assistant in your systems, whether it is, Microsoft's voice assistant, or it is Google Assistant, any assistant you are using, all of them for sure are using natural language processing. Any chatbot that you are using through, if you are interacting with any chatbot, आप सभी ने कभी ना कभी complaint definitely किसी website पे डाला होगा, whether you have, bought something from Amazon and you want to return something, or you have certain issues with the product or its receiving, its delivery, whatever. So if you have any grievances, they directly navigate you to their chatbot. Why so? Because chatbots nowadays are so efficient, they can understand what you are trying to convey them through your text, because again, the power of natural language processing is inbuilt in them, and then that they take the necessary action that is required. If ultimately they are not able to help you out, then they navigate you to the human assistant. Otherwise, only the voice or the chatbot assistant is there for you, right? So that is the essence of NLP and its uses, its applications that you can see nowadays. So NLP is a branch of AI that focuses on interaction between humans and computers by the human's natural language. देखिए, समझना तो हमें है ना, हमें कंप्यूटर को समझाना है और हमें कंप्यूटर की बात समझनी है, सिंपल भाषा में बोले तो जो लैंग्वेज है वो तो नेचुरली रहेगी। आप कोडिंग कर सकते हैं, बट द पॉइंट इज यू वांट टू मेक सिस्टम टू अंडरस्टैंड what you want to convey through your speech and through text, and you want to understand in the same manner what computer wants to convey you as the solution, right? So that is what NLP deals with. So the ultimate objective of NLP is to enable computers to understand, interpret and respond to human languages, right? Okay, so you can see a simple figure in front of you, where in between we have this Venn diagram, and in the middle we have this NLP, natural language processing. So what we can say is that NLP is a combination, or you can say NLP is the intersection point of three domains majorly. Okay, you can see a lot of Venn diagrams where different technologies are embedded and integrated to form NLP. But as far as the beginner level is concerned, what we generally think is that NLP is made up of the intersection point. It is an intersection point of three main domains. One is the computer science, because you are going to use code for it. Second is the human language, because you are going to use languages. Okay, either you are going to use English. Now language, when I say now, don't misunderstand that it is going to be only English. We are going to today work with different languages. We are going to see Hindi language also in action in NLP, French, Spanish, Chinese, whatever language you have, just you need that code. So that is why computer science is important, to write the code. So you need the code. You want a code for the specific human language for which NLP library has access to, or it has the complete training for it. So whatever languages we have, all more 50 plus languages in NLP, okay, through which we can actually convert the speech, or we can create language translators, right? So we have 50 plus languages anyhow. So AI is also required, because directly you cannot simple application of converting languages doesn't work, because we need to have some advanced languages, advanced applications, where like we have certain specific applications of creating chatbots, of creating voice assistants, of creating any kind of website integration. So for that we need specific tools that can be provided with artificial intelligence. So this is the intersection point. NLP serves as the intersection point for all these three domains, right? Okay. So what are the main two categories of NLP? What are the two major, you can say, the branches or subsidiaries of NLP? One is natural language understanding, second is natural language generation. देखिए बहुत क्लियर है, अगर आप इसको समझेंगे कि NLP दो चीजों में डील करता है. One is you want the system to understand what you are telling, and secondly you want system to generate something that you can understand. Okay, so these are the two domains that are actually the same as they convey through their names. So NLU stands for natural language understanding, which deals with basically computers understanding, the system's understanding of what you are actually trying to convey through either your speech or through your text. And natural language generation is the other way, where your system is generating something that you can understand. It is generating certain text, it is generating certain images. So generative AI is a big branch, and NLG is a text related branch of generative AI, where you are actually trying to generate text out of it. Your GPT models, your transformer models, your LSTM models, BERT systems all come under the category of natural language generation. Okay, so let's begin with it. Okay, in the meantime, just guys give me a check, like are your systems ready? Like they are all the installations are done, or is it still pending? Just give me a quick check. Is it still pending, or are you done with the installation part?
We have a message that one of the
Okay.
person is not able to download Jupyter Notebook. She wants to
Okay.
work on Google Colab. Can she work on
Yes,
Google Colab?
yes. Yes, Ramita ma'am, not an issue. You can directly work on Google Colab also. If any one of you is unable to, install Jupyter Notebook, that's simply okay. You can work on Google Colab. There is not an issue. Okay. You just been needing the internet access and that's it. Otherwise, you don't need anything else, right? You can directly work on Google Colab. Not an issue for me. Okay. Okay, any other doubts or any other issues anybody is facing, just give me a check. If you are facing any issue, then please do let me know so that I can help you out in the installation process or in any other issues that you are facing. Just give me a quick check. Are you able to do it, guys? You can also just react it through emoticons, right? You have emoticons also, so you can just react also. Like, are you able to understand, or do you have any issues you are facing, or you are facing any trouble in installing things, right? So you can also send that to me through reactions or through your chats. Okay, thank you so much, guys. Fine, let's come back to the point where we were discussing. So okay, I think we got a message. Not able to install Jupyter Notebook. Manoj Purohit sir. Okay, Manoj sir, are you getting certain error in it, or what exact issue you are facing? Are you facing certain issue? Then you can just write down the issue, or else what you can do is you can directly go to Google Colab. Let me just show you how you can directly log into Google Colab also. So we have this Google Colab option. You can just log into Google Colab. I hope my system is visible and you are able to see the Google Colab interface that I'm opening, right? Okay, so this is the interface of Google Colab. You can directly open a new notebook through here. You can see this is the pop-up that is coming for opening a new notebook, and you can directly open a new notebook from here, right? So you can see on my system, it is trying to open a new notebook. For the first timers, like if you are logging into first time, what you can do is you need to log in through your Gmail account, right? So if you are logged in through your Gmail account, then you can easily open Google Colab. Okay. Anyhow, I hope, sir, now it is okay, everybody. If you are unable to install Jupyter Notebooks in your system due to trouble, then definitely you can work through Google Colab. Okay. I hope that is okay. Fine. Okay, great. Okay, sir. Thank you so much. So this is your Google Colab. Keep it open, right? Everybody, please keep it open. And if you write something, you can just play through this play button, right? You can do anything. Say print. I just write down print hello. Okay, and you can just play through this. This is just a simple liner, like if you are starting to work through it, then this is the way. This is known as a cell. So this cell is being done, so it will print or it will give the output just below that, right? So for the first timers, this is how Google Colab interface looks like, and this is how you're going to work with Google Colab, right? Okay, fine. Coming back to the rest of the things, let us discuss ahead. Okay. Yes. Okay, so we were talking about NLU. Okay, so natural language understanding, it focuses on observing and understanding the meaning of the given user input. क्योंकि आपने तो कंप्यूटर से बात की, आपने तो उसको कुछ कमांड दे दी. Suppose for example, I open Alexa and I say, okay, Alexa, play music by Arijit Singh. Okay, he's my favorite singer, so I'll just name him. So I'll say, okay, play Arijit Singh songs. So now Alexa is what going to do? Alexa is going to understand, first of all, your command. It is going to say, okay, what is the verb over here? Verb is say playing. So that means you want me to, do some action. Then it is going to pick up the nouns. Okay, the noun, the proper noun that I have is the name of the person, Arijit Singh. So who is Arijit Singh? He might be a singer because I am asking Alexa to play some music. So he might be a singer, he might be a movie, he might be any particular chartbuster, or he might be anything. Okay, so it is going to search in its library through internet. It is going to see, okay, who is Arijit Singh. Finally, Alexa will be able to retrieve all the results of Arijit Singh, and it is going to start plug and play directly the songs of Arijit Singh. It is going to give me a message, okay, playing songs from the list of Arijit Singh, and then it will start playing the songs. So the process has been, what command I gave to system created a corpus from it. Corpus means a small dictionary from it, a small collection from it, and through that collection, it has tried to understand what I want to convey, the message, right? So it has tried to understand through simple grammar, because I am using English language, so it is going to use the simple grammar for understanding, like what is the verb, what is the noun, adjective, adverb, what I'm going to use. And if I have used certain that particular word which actually directly it does not understand, it will try to look for a synonym of it, and then try to understand it, and then play the thing. Okay, try to do, execute what I want him to do, right? So this entire process is natural language processing, which is mainly focused on understanding the meaning of the user input, what input I'm giving. The system is trying to divide, bifurcate things. It is going to understand each and every bit of information in the input that I have given to it, right? So NLU focuses on machine's ability to understand and interpret human languages. It involves passing, comprehending input text into its exact meaning. Okay. So there are different components of NLU. So the different components, the first component is intent. Okay. So intent means the intention, what actually you want the system to do, what actually you want the system to execute, that particular intention. It is going to understand. First of all, like I asked Alexa to play Arijit Singh's songs. So now Alexa will understand what is my intention. So my intention, that I want Alexa to play it, to execute that thing. Similarly, in the sentence, for example, I've given book a flight to New York. Okay, so here the intention is to book a flight. So booking is the main action or intention that you are, that you want the execution of. So intention actually refers to the execution part. Now, coming to entity recognition, the second component is the entity recognition, which means what exactly that, understanding the noun. or understanding the entity part, because there are two main components of English language. Okay, so English grammar में जब हम पढ़ते हैं तो दो main चीज होती है जो हम पढ़ते हैं, one is verb and one is noun. मुझे इतना ही याद है main जो grammar में हम पढ़ते थे. So I think that is the most important thing that actually has been imbibed into natural language processing also. So we have the verb, that is the action that needs to be done, and then we have the noun. Noun means any proper noun in the name of the location, the name of the place. जो मुझे याद है बचपन में हम लोग पढ़ते थे सभी, the name of the person, place or any entity, any other thing, okay, is known as the noun. तो वो चीज यहाँ पे fit होता है, because entity is only that particular noun. It refers to that particular name of a thing. Now these entities have to be, you know, a part of some important thing. Either it has to be the name of certain particular place, or name of a person, or name of any particular thing that system can recognize. Okay, so that is the point, that it has to recognize the entities. Okay, for example, if I say play Arijit Singh songs, then Arijit Singh itself is the name, he is the noun, right? Similarly, in booking a flight to New York, New York is the name of the place, so it is again a noun. So understanding is, first of all, understand the verb, that is the intention, what you actually want it to do. And second thing was entity recognition, that is understanding the name of that particular thing, the noun part. Okay, so these were the two components. Other components we also have semantic parsing. Semantic parsing says analyzing text to understand its meaning and structure. Now, analyzing the entire text. Okay, so booking we have to do, New York we need to do, but do we have other specifications also, other semantic information also we have, like what you want to book? Book an air flight, book a cruise, book something, you know, book only New York may be the name of the movie. Okay, you want to, you know, book movie tickets to the movie New York. Okay, so it has to, you know, semantically parse it. It has to divide each and everything. It has to tokenize things. It has to understand each and everything apart from the verb and the noun. Because action मालूम पड़ गया, हमें ये मालूम पड़ गया, हमें noun क्या है, किस डायरेक्शन में जाना है, लेकिन एक एक वर्ड को पहचानेंगे तभी डायरेक्ट हमें ये मालूम पड़ेगा कि एग्जैक्टली पूरा का पूरा स्ट्रक्चर क्या है, पूरा काम क्या है, सब्जेक्ट क्या है जिस पे काम करना है. ठीक है, फॉर एग्जाम्पल कन्वर्टिंग book a flight to New York into a structured format that actually system can act upon. So that is the main thing which you know, is composed in semantic parsing. Then we have conference resolution also. Conference resolution says identifying when different words refer to the same entity. For example, देखिए कोई कभी कभार हम इसमें nouns का यूज करते हैं पर proper nouns नहीं होते हैं. आप इसमें कुछ इस तरीके से यूज कर रहे होते हैं, जैसे आप किसी person की बात करें, then you suddenly start using he, she and so on. So understanding what she refers to, what he refers to, what it refers to. Okay, so that noun part is also comes under the category of conference resolution. So for example, in Alice told Bob she would come. Now Alice and she, you know, you are trying to convey here that Alice is telling to Bob that she will come. So she is referring to Alice and not Bob. Okay, so that, you know, that referencing that particular part, so it is known as co-referencing, where you are actually trying to refer, you know, co-refer some particular proper noun with some non-proper noun. Okay, so this is how it is being done. The next part is word sense disambiguation. Disambiguation means determining which meaning of a word is used in a given context. Okay, for example, like just see here, in I went to the bank to deposit money. Now bank, this word has two meanings. One, bank is your financial institution. It is the financial bank where actually you go to deposit certain money, or you just try to, you know, do some financial transactions through your bank. Another bank also we have, which is the river bank. Okay, so which is the riverside or the river bank. So system has to understand that which bank we are talking about, because it may be like I went to the bank, it may be the river bank or the riverside, but no, it is related to money, it is related to some financial transactions. So that correlations, that word embeddings, that relationships between different words is also important to sense. So that is known as word sense disambiguation, where we are trying to embed the meanings of the words, the relations of the words, the exact purpose of that particular word with the help of its relation to other words. So that disambiguation, you know, that इसको हम अगर simple बात बोले तो ambiguity हटाना, वो चीज, that comes under the category of word sense disambiguation. Okay, so these were the these were the 5 components of NLU. We are just coming to the application part. Just we are going to see how NLU comes into action. And we have these applications of NLU where we are trying to work with sentiment analysis. Today we are going to see an application of sentiment analysis. We have topic classification also. We have entity detection also. So these are the 3 main research areas or applications that all of you may have worked upon. Okay, or you may be working or doing some research work on this. So these 3 are just example of these applications, simple examples, which are broadly in the category of NLU. Okay, and real world devices, if you see what NLU is, integrated into, are Alexa, Siri, Google Assistant, where you are actually talking to that particular device, and that device is understanding what you are trying to convey, and then it is performing that particular action. I say, okay, Siri, just give me today's weather report. So it is going to understand, okay, I need to retrieve it from some weather application, and then I just need to give that particular report to the person. Today's weather report I need. Okay, so this place, it has to recognize which place, the location, and then it has to navigate to a particular site which is going to give the current weather application, and then it is going to convert that text, whatever it has retrieved, into speech, and then it is going to convey to you and talk to you the same manner as 2 human beings talk to each other. Okay, so this is how the entire working of NLU is focused on. Okay, now before going ahead, let us do some action. Let us see NLU into action, how we can just do a simple application and see how important or how efficient NLU can be. Okay, let us see. Okay, guys, so let me share my screen with you. Just hold on. Yes, okay. Okay, just give me a second. I'm sharing my screen once again with all of you. Just give me a check. My screen is visible. Yes, just give me a quick check, everybody. My screen is visible to you all. Yes. Sonia ma'am, I hope my screen is visible to everybody.
Yes, ma'am, it is visible.
Yes.
It is
Okay.
showing
Thank you.
some popular NLP libraries.
Yes, yes, ma'am. Thank you so much. Okay, so just understand this thing. We have a set of libraries in Python that we can use in NLP, right, for natural language processing. These I have given you a glimpse of 5 such libraries. Apart from that, we will be using other libraries also for different purposes. But as far as NLP core is concerned, these are the 5 libraries that we have. So first library is Spacy that I'm going to just use, okay, for showing you the action of NLU and NLG. So I'm going to work on Spacy. So Spacy is again an open source NLP library that you can directly use for data extraction, analysis, sentiment analysis, and text summarization. One of the best libraries we have, that is Spacy. Okay, even most of you, maybe you all have used NLTK, Natural Language Toolkit, but I can assure you that if you start using Spacy library for your work is going to be quite quick, quite fast. Okay, because it is time efficient, it is quite you can say speedy as compared to NLTK. Anyways, NLTK has its own charm, it has its own applications, it has its own functions and classes that are present in it, but Spacy is also good one if you try to start working with it. Okay, apart from that, we have scikit-learn also, because we need machine learning also when we are talking about NLP. Okay, for example, like if you want to classify sentiments, if you want to classify text, if you want to classify topics, okay, so all these classification things, they come under the category of machine learning. Where suppose we want to classify our text, whether the text is related to some drama areas, or it is related to some news areas, or it is related to some sci-fi movie area. So we need to classify that text. Okay, so that text classification can be done with the help of machine learning applications. So NLP also makes use of scikit-learn, which is dealing with the complete machine learning library. Okay, so NLTK, we all know it is the natural language toolkit. So NLP is most of the times, the purpose is solved by using NLTK. Then we have text blob also, because nowadays sentiment analysis is very important. Because I was lately we were with in conjoint with DSEU, and in conjoint with other organizations that I won't be able to name it now, but I can tell you about a project. That project was about suicidal tendencies, increasing suicidal tendencies among middle-aged people and among youngsters. Okay, so what happens, like, before a person actually goes for suicide, committing suicide, that actions, or that intentions, they are quite clear through their speech also, through their words also, through the text also that they write. Okay, if you, any of you would have been working in this domain, then this is, many projects are being developed into this area. So one such project I'm discussing with you. So what was happening, we were trying to work on a project where we were having, a data set of those people, the 1 month or 2 months before they actually committed suicide, what actually they were scribbling on their notepads, what actually they were scribbling, or what they were searching on their laptops, and what actually they were talking to their friends or to their family, or they were not talking at all, they were being very reserved, or what was their the kind of speech, the kind of text that they were scribbling. So if that data set can be created and that data set can be trained, then you can actually predict the sentiment of the person in the context of how much negative, how much positive, and how much total compound sentiment from that text you can achieve. So the more negative content you are achieving, the more prone towards self-harming or some danger towards harming others. If you can detect that in advance through the text or through the speeches, automatically if we create an application that can analyze the sentiment behind those people, then we can actually save some lives, and we can also reduce crime also. So that is the major crux of the project that is being under the aegis of some prominent organizations. So what they are trying to develop, they are trying to develop an application, that an app that can be simply integrated into your phones, that can actually detect, or that can stream in what you are talking. If it is going to be very, very negative, it is not going to record, and it is not having any particular purpose, but the purpose here is for those people who may be prone to depression, who may be prone to suicidal tendencies. Okay, so that the entire thing that I'm telling you is because this project is related to sentiment analysis, a very advanced, you can say, application of NLP and sentiment analysis for detecting sentiment through their live chats, through their live speech, through their talking, through their scribbling, and all those things. Okay, so the libraries that you can use for such text training, or speech training, so the text training is can be done by text blob library. Okay, text blob library, anyhow. So this is how it can be done. QPy also, QPy is being used, QPy, TweePy, these are basically used for live streaming from some social media, because we have TweePy also, which is actually used to live stream tweets from X, which was earlier Twitter. So you can live stream tweets from those particular things, and then you can collect your own data set, and through that text you can train your system and do certain processing in that text. Okay, so these kind of things. QPy is also used for queries, by transforming text into queries. Okay, for through DQL, data query language, database query language. Okay, anyhow, so these are some of the most popular libraries that we have in NLP. Now coming back here, uh, everybody, please quickly install Spacy. Let us do a particular uh, working in NLU and NLG. If you try installing, if you are trying installing in Jupyter Notebook, please, you can see my screen. You can simply put an exclamation sign, and then you can write pip install Spacy. And in the Google Colab also, please install Spacy, everybody. through this command. Just give me a quick check once you are done. I need to keep on checking this particular thing. Okay. Yes. Are you able to install it, guys? Everybody, please give me a quick check. Are you able to install this? PIP install Spacy. Are you able to install it? In new versions of Google Colab, I think you all may be having updated versions. So in Colab, you might not be needing to install Spacy. I think it comes pre-installed. So you can just check. It may be giving you requirement already satisfied, right? And others in Jupyter Notebook, if they are working, then you might have to install Spacy. And you, because I have installed Spacy already, so if I execute it, I always get requirement already satisfied. Okay. So just give me a check. Are you able to do some error? Okay, Manoj sir, you are facing some error. Can you just type in what exact error you are facing? Others also, are you able to install Spacy? Just give me a quick check. Are you able to install Spacy? Okay, those who have already installed, the next thing is that you need to download the English language model also. Okay, so the English language model can be installed by this particular command. So I am putting this command in your chat box. Yes, yes, Sonia ma'am, you are correct. Google Colab has already Spacy installed in it, right? Because you are logging in it and it has the GPU, and GPU has Spacy already installed in it. I have sent the command to download the English language model also. So this is in Jupyter Notebook. This is a mandatory step. You need to directly download things and you need to use them, right? Before actually using them, you need to download and install things in Jupyter Notebook. Okay. So I have also given this command in the chat box. So everybody, I think you can just take the command from chat box. This command is for small English language model that you want to install. Okay, because we need to specify to our system that we want to use English language as of now, and the vocabulary that system can understand and check whether it is a verb, noun, and everything. So it needs a base model for it. So the base model for English language checking is NCore Web SM. So they need to download, everybody needs to download NCore Web SM, right? So I hope nobody is facing any issue in it. Everybody has done it. Just quickly do it, guys, everybody. Yes, are you able to do it? Done. Thank you, Dr. Madhvi. Thank you so much. Sonia ma'am, you are also done. Okay. Manoj sir, I hope you're not facing any issue right now, right? Okay, let's go ahead. Now, once it is done, let's come ahead. Let's see a simple example of NLU. Okay, so I'm just zooming it in. You can just see a simple example of NLU. So what I'm going to do, I'm just going to give you this particular code, or you can just type down this code where we are importing Spacy, and we are creating a variable NLP. So NLP here is a variable, and I'm using Spacy to load the model that we have just downloaded, NCore WebSM. So it is going to load the NCore WebSM small model of English language. Okay, the downloading has already been done, but loading it into RAM now needs to be done. Okay, then the text is the same thing that we had seen in the example. In the text, book a flight to New York next Monday. Okay, so this is what we actually need to give to the system. This is just a command that we are giving to the system, but we are giving command through text. We are not using speech as of now. In the, as the day progresses, definitely we are going to work with speech also, but as of now, for being at the very beginner level, we are going to use text for this. So text is book a flight to New York next Monday. So this is the text command that we are going to system. We have given this to system, and then we are creating a document out of it. Now document is something which system is creating, and system is actually creating complete documentation for this command that we are giving. It is tokenizing it, we are going to learn about these things. It is going to tokenize it. It is going to convert it into words. It is going to see the lemma. It is going to do stemming of it. That means it is going to take it to the most root word that it has. Okay, so that it can easily understand. The system can easily understand things. So we have created a document where document equals to NLP.text. So this NLP variable already contains the English language model. So now NLP can be used as the text interpreter. So NLP variable is now being used as a text interpreter for this particular text, book of flight to New York next Monday. Now in this documentation that it has created, so NLP has now interpreted this text and has stored in the doc. So now we can use a for loop for ENT. ENT is simply the iterator that we are creating. So for ENT in doc.ENTS, ENTS means the components. So the short form for components is ENTS. So whatever components are there in the doc, that means the words that it has recognized in English language, it has recognized the nouns, the verbs, it has recognized the dates, the persons, everything that it has recognized, that is created inside the documentation, right? So we want to print everything. So for ENT in doc.ENTS, we want to print two things. First is the ENT.text. Text means the actual textual value that it has recognized, whether it has recognized this New York, it has recognized this Monday, it has recognized book, whatever it has recognized. Okay, comma ENT.label underscore. So label underscore means the category under which labeling, under which category this word comes. For example, here the output, once you execute this, you are going to get these two outputs. You are going to get New York as GPE. GPE means geopolitical entity. So this is, a geographical or say geopolitical entity. It is related to politics also, it is related to geography also. So that is why it is giving you geopolitical entity. And Monday is the date. So it has recognized very, very important nouns, and it has classified that nouns into categories, into labels. So we just wanted to see how system perceives or understands what we give them as the command. Okay, so I'm just giving you this particular code. If you are unable to do this, or you are getting some error, you can directly use my code, whatever I'm sending you. I'll be giving you these codes, so don't worry about the codes also. By the end of this particular session, okay, in the evening, Sonia ma'am, I will definitely give you this entire code also, so that people can go through these codes once again. Okay, so these codes I've created for you people. So I will definitely give all the codes. So don't worry, even if you are unable to execute the entire thing, I am going to give you code. You can also go through these codes, and you can use them for your development, right? Okay, fine. So just give me a check. Are you able to do this? It's running. Thank you so much, Dr. Madhvi, for this confirmation. Everybody else, Sonia ma'am, thank you so much for the confirmation. Rest of you guys, I just hope that everybody is able to understand this. It is able to understand how the system is understanding things, right? Okay. So what we need to do now, let's change something. Okay, instead of this booking, let us see.
Nidhika,
Yes, ma'am.
once can you please explain this output again, New York GP, and can you?
Yes, ma'am. Definitely. I'm just explaining this once again. Just see this. See the output of this. We want what NLU is. See, NLU होता क्या है? NLU understand करने की कोशिश करता है. आप जो भी कमांड उसको देते हैं कि उस कमांड के अंदर उसने क्या इंटरप्रेट किया, उसकी अंडरस्टैंडिंग क्या है. NLU understanding of the systems, that particular branch it is dealing with. So here, if we are giving this text, say book a flight to New York next Monday. Okay. Now here it is trying to catch the most important words for its understanding. The first word that it is understanding is New York. New York is what? New York is some place. It is a destination. So that is why I have printed the text that it has understood plus the label that it has classified that particular thing. अभी देखो ये बहुत सारा क्लासिफिकेशन होता है, इसमें टोकनाइजेशन भी होगा, इसमें लेमिंग भी होगा, लेमिटाइजेशन होगा, स्टेमिंग होगा, NER होगा, नेम्ड एंटिटी रिकॉग्निशन होगा. तब बुक फ्लाइट हर चीज को वो अंडरस्टैंड करेगा, हर चीज का एक ग्रामेटिकल एस्पेक्ट निकालेगा. बट जब तक आप NLU का अगर बेसिक, मैंने अभी कुछ नहीं किया इसमें, मैं सिर्फ बेसिक देख रही हूँ कि एक लाइन से सिस्टम क्या पहचान रहा है। तो इस पूरी लाइन में सिस्टम को दो ही चीजें इंपॉर्टेंट दिखी हैं जो मेन नाउन्स हैं, वो है नेम ऑफ द प्लेस न्यूयॉर्क, जो उसने पहचाना, एंड उसको किस कैटेगरी में डाला। सो GPE मीन्स जियो पॉलिटिकल एंटिटी, सो दिस इज द कैटेगरी ऑफ न्यूयॉर्क, ये अंडरस्टैंडिंग है सिस्टम की। दूसरा नाउन जो उसने पहचाना है इस पूरे सेंटेंस में, दैट इज मंडे, एंड मंडे इज रिलेटेड टू calendar and date, so the category where this time falls is date. Okay, so this is how system is interpreting this line. Okay, so for example, book a flight to New York next Monday. I want to eat an apple. Okay, let us see. Now, and see this, I have changed in front of you. I have changed my sentence. What I have done, I have added on to this, I want to eat an apple. Now just see this. We have still not pre-processed it. We have still not created a corpus, and we have not done any of the pre-processing part. So what it is understanding is, apple is what? Just see this. It is not able to take it as a fruit name. It is in fact taking it as ORG. ORG means Apple organization, Apple company. So it is taking it to be Apple. So we need to do further pre-processing. We need to, have that complete aspect of NLP, all the components, all the pipelining, everything we need to understand. We need to implement for the correct implementation of thing, or for the correct classification of things and text generation. But as of now, if you see what Spacey and what NLP is doing is, it is understanding main three nouns. It is understanding New York, which is a geopolitical entity according to it, which is correct. Monday, which is again a time that is related to dates, and Apple, which according to NLP is a company, because it is, this NLP library is trained to understand mostly that Apple is a company, Apple is an organization, until we give it any other further uh, instance or any other further training, right? I hope this is now clear. Like, this mainly understands what computer understands, what your system understands by your commands. Okay.
Thank you so much. Thank you.
Okay, okay, fine. So this is how NLU is working, right? Okay, coming to the next component, this was a basic glimpse of NLU. Now coming to the next part, which is NLG. Okay, let's come to that part also. Okay, what is NLG? NLG is natural language generation. So it is described as a translator that converts the structured computer data into corresponding natural language representation. That means it is, using a particular thing to understand whatever you are giving it. It is understanding, it's trying to understand that, and then generate something new out of it. So this NLG is that particular domain which is related to generative AI. And specifically in generative AI, there are many things that can be generated, guys. Like, we have tools, we have ChatGPT tool, we have Bard tool, we have Microsoft Copilot also, we have GitHub Copilot also, we have so many tools nowadays. Microsoft Bing also we have, Bard also we have. Bard is nowadays, I think, depreciating. So Mid Journey we have. So some of these tools are used to generate images, some of these are used to generate text, but NLG is concerned with generating new text out of it. So if we are going to give us some particular text that system can understand, that system can train upon, and it is going to generate new text from that particular thing that we have given after training, right? So it involves establishing natural language outputs for non-linguistic inputs. Okay, so areas where NLG comes into play is generating analytics reports in natural language like Spanish, English, French. Mostly we train the system for these, but we have 50 plus languages. I'm going to show you all of them, right? So you enabling chatbots to interact in a more efficient way, and automated contents like articles, stories, etc. Coming to NLG's components, before I actually show you a GPT model and I create a text generation, very small application of text generation, before I create that, it is important to understand like what NLG, takes behind, what exactly is the background process in which NLP, works. So first is content determination. So content, it is going to understand first of all, because NLU and NLG, they play together. When NLG is working now, NLU and NLG both need to play together. So first thing is to determine the content, to see that what exactly you want to determine, what exactly you want to generate. So for example, in a weather report including temperature, humidity, and weather conditions. So for example, I'm just going to show you one simple example for this also, you will understand through that. So suppose I give a small phrase and it is going to complete it. It is going to generate text out of it. So the first thing for generation needed is content determination. Next is text planning, organizing the structure. Okay, where exactly noun has to be placed, where exactly verb has to be placed, so that complete corpus, the text can be planned. A complete structure of that English related, if I'm talking about English or any other language, the grammar has to be followed. The structure of that exact text needs to be planned. Okay. Now, third thing is sentence segregation, where we have, if we have multiple pieces of informations, we have multiple things, we for example, we need to generate multiple words, 500 words, 1000 words, then aggregation needs to be done. The relationship of the sentences into a paragraph, first of all, words into sentences needs to be formed, and then sentences need to be aggregated to create a complete paragraph out of it. So that is where sentence aggregation comes into play, where you are merging things. For example, merging the temperature is 20 degrees Celsius and it is sunny into a complete sentence, a structurized sentence which says the temperature is 20 degrees Celsius and it is sunny. So it has combined two things and gave you a complete sentence without breaking it. It has given you a merged sentence. Okay, so that aggregation also needs to be followed when it is generating a new text. Okay, then lexicalization is important, choosing specific words to express the content. Okay, for example, you can see rainy. So here basically you can understand the synonyms use karna mainly. Lexicalization means using alternate words. You are creating that lexical structure where you are trying to use the alternate words for it. For example, you can use rainy instead of precipitation. Okay, so precipitation is that kind of very technical word. If it needs to be used within some chemistry kind of a thing, or in a very technical domain, then you can use precipitation. Else, if a naive person, if a naive user is asking about the water or the say the weather report, then you must use the word rainy for that, not precipitation. Okay, so that kind of lexical decision making comes on also into action in energy. Last one is surface realization. So converting abstract representations of content into grammatical correct sentences. Again, it has structured things, it has aggregated things. Now the point is now aggregating sentences to form a correct grammatical paragraph or a grammatical big sentence. Okay. For example, generating the event will be held next week at the Central Park. Now this is, a better approach. Instead of this event will be held at Natural Park next Friday. Now, grammatically, the correct interpretation is what you can see on your systems. But when we speak, when we use different versions of that same sentence, we can use next Friday after at Central Park. Okay. So it has to decide that realization has to be done how grammatically different phrases, different words, different aspects of that particular language needs to be combined together to give you a properly managed sentence. So that is what surface realization comes into play. Okay, so this is how NLG works. These are the small components of how NLG is working. Okay, before we move ahead, let's do a small application through GPT-2 model for text generation. Let us see text generation. Okay, so coming to the example of natural language generation. So you can see on my system, what I have done, I have used the transformer model, which is again one of the large language models. In the afternoon session, we'll talk more about it and we'll create a big application from transformers. But as of now, I can just give you an intro to this, that transformers are a type of, again, large language models which are being used in GPT-2 models. Okay, so GPT-2 models which are totally connected to generating text text values, generating and completing text values. Okay, so from transformers, so we have used this model. We have imported these two classes, GPT-2 LM head model and GPT-2 tokenizer. These two libraries, they deal with two things. First of all, GPT-2 head model is actually used to create sentences, to create words, to generate new words. Okay, and GPT-2 tokenizer is mainly working to understand the meaning and relationship of words with each other. Okay, so it is used for understanding the meaning of the tokens. Tokens means words here. So it will understand tokens and the relationship between tokens. Now we are going to create a tokenizer from here. We are going to use this GPT-2 tokenizer. We are going to create an object of this class. So tokenizer is basically the object of GPT-2 tokenizer class dot from pre-trained GPT-2 model. So this is a predefined GPT-2 model which we are going to use here to generate a new text. Okay, and model, again we are going to train a model through this GPT-2 head model, because it is going to create the corpus, going to create the bag of words automatically. So we are going to create a model from GPT-2 head model from pre-trained GPT-2. Again, GPT-2 is the model, the name of the pre-trained model that we have. Okay, now this is my input text. I can give you any input text. So I was just giving you an example in the text about the weather. So I have given here the weather today is. Now the task is that system must generate and complete this entire sentence. I have given a phrase, the weather today is. For example, I ask Alexa, what is the weather report today? So that was my question. Or I ask Alexa, how the weather is today. Or I ask, say, Alexa, the weather is, and I just stop it. So I can ask many, many types of phrases or questions from Alexa. The same thing is here. We can ask input text, the weather today is. It has to complete the sentence. So input IDs, I need to specify the input IDs. What are my input IDs? I need the tokenizer object to encode my input text. Whatever input text I have, it is going to encode. Encode means simply convert the text values into machine language. It is going to encode this text into machine vocabulary, into machine language, and it is going to return tensors in the point values. That means it is going to return me some important or say related values. It should only return me those words which are mostly related to, most relevant to the input text that I'm giving. So it is going to encode my input text, and it is going to return me only those tensors, those values, those words which are most importantly related to this particular phrase. Okay, now output has to be model.generate. So now I'm using this model to generate those words, okay, new words for completing this sentence. So model.generate, it has to use these input IDs where encoding is being done and tensor has also been told to them. Max length is 20. I can generate more than 20 also. I can say if I want to generate say 100 words out of it, so max length can be 100. Num return sequences equals to 1. So sequences means number of sentences or number of sequences that you want, can be 1, 2, 5, 10, whatever you want to return, you can return that. So print tokenizer.decode. So now we need to print it. We need to decode things. Now understand this thing, when I'm giving input, I need to encode my input into machine level language so that machine can understand that corpus. Similarly, when I'm printing it, I need to decode it. That entire machine generated values must be decoded back into that particular language that I can understand. Okay, so print tokenizer.decode and output 0. So output, you may be having many, that when the output buffer is created, the first 0th list, the 0th value is actually the values. Rest are the different dependencies and configurations that are given in the buffer. Okay, so you just need to decode the output 0. That means the actual output that you have. Then special sequence tokens equals to true. So if you have any special sequence tokens like commas or double quotes also there, exclamation sign also there, that special tokens can also be included into our generated text, that must also be visible to us. Okay, so I'm just going to give you this entire thing, right? So I'm going to give you the entire standard code that is running successfully in your chat box, and you can take it from there and use it to directly run it, right? So now as soon as I run this code, you can see the output. Okay, it may be giving you a warning, so you can just ignore that warning. It is all about token IDs and open-end generation and all those things. You can just forget it, right? So it is saying me the weather today is very good, and we are going to be able to get some good weather tomorrow also. So it is going to give me this output. It may give you different output. It may give you same output. It depends on the how the system is working. Okay. So this is how it can be done. Okay, I can change it. I can just say the rainy. I can just add a few words to it, and I can just run it, and it is going to play something for me. Okay. Now, the rainy weather today is a good sign for the future of the city. So now you can see it is giving me some, this kind of output, but it is generating. Okay, it is giving you, because I am not, training it. I'm giving you a very small uh, sequence of code. This is a very, very brief code. Okay, we have given just a simple sentence. We are not giving any training. The GPT model is learning from these 5 words only and then generating something here. Okay, you can also just say uh, the stock market today and try to run this. We can just try to do it with different aspects of text. Okay, it can generate new values. So the stock market today is a very, very volatile market. The market is volatile because of the volatility of the, now it is giving me only half of the sentence because my generation, the length generation was a bit less. It was 20. Let me make it 200 and then run things. Okay, and now you can see a paragraph being forming up over here. Let me just zoom it out. The more length you give to your words, it is going to take time to generate, because generating 10 words, 20 words is far easy, but when it has to find correlation between words and their meanings in the sentences, arranging them, forming paragraph out of it, it may take some time. Okay, so we need to be patient. Rest of you guys, just see, it has generated a very, very nice thing. Okay, just see to this. Fine. Okay, so number of return sequences. Now what it is doing, it is always okay. So it is always giving me the first sentence because I'm just trying to print output 0. But anyways, you can just run things on your end, right? So the stock market today is a very volatile market. The market is volatile because of the volatility of the stock market. Okay, again, it is repeating the same blah, blah, blah. So it is generating 200 words, but it is generating the same kind of thing. It is not trained. It is trained only on the 5 words. Okay. Otherwise, if you just make it 20 words, 25, 30 words, it would seem to be more relevant because the text is very small. Okay, anyways, we are going to work on the project where we have entire web page to scrap, and then it is going to create a better output. Okay, because of this. So anyhow, we are now through with this, that how it is generating new text. Okay, any other implementation? Okay, let us try to do this with the weather today is. I hope a more generic may work in a better way. Okay, are you able to do this, guys? Everybody, please give me a check. Like, are you able to work with it? Are you able to do it? It's a bit of a mess. I've been using it for a month now, and it has been working great. Output generated. Okay, not an issue, ma'am, because it is generating. It is not we are just using only 5 words, and it is using the pre-trained GPT-2 model. So we have not given it a very a very good library or a collection of words, a library of words or a collection of words to train itself. We have given just 5 words, and be happy that it is generating new things from 5 words. So this is the small action of NLG. That's it, nothing more than that. Definitely we can, if we are able to give our system a big collection of words, a big article, a big paper, then it can generate new text out of it, then it can generate new things out of it. But as of now, we have given it only 5 words to train. Okay, very hot and humid. Okay, if you try to improve the things, if you try to give it more things to understand itself, to learn, you can see here now, I have increased my words. I have increased the type of words that it can see. Now you can see it is giving a better result. It is giving, the weather today is very hot and humid. The wind is blowing very fast and it is very windy. Now again, it is started repeating things because, the sentence that we are giving is very small. If you give a big paragraph to understand it, then it will generate more words out of it. It will generate new text out of it, right? I hope, Sonia ma'am, that makes sense, right?
Yes.
Yes. Okay. Thank you so much. Everybody else also, like, are you able to do this? Are you able to understand this and generate it? I have already given you the code in chat box, so you can directly take the code and do all the, different implementations, experimentations with that. I hope we are good with this. We can move ahead.
Yes, ma'am. Yes.
Yes. Okay. Thank you so much for the confirmation. Okay, guys. So this was like two main things. We have seen NLP working on text. Okay. So in the first example, it was understanding the text that we have given and it was giving us the exact thing what it understood by our text. Okay. Because again, these are very small implementations. You might not expect the NLP to understand each and everything very accurately. Slowly we can optimize its accuracy. Slowly we can optimize the efficiency of our model. But as of now, we are using the pre-trained models for implementation. So they may give you a less accurate results, but I am happy that they give results. Even if with 4 words, 5 words, they are generating things for you. The GPT-2 model is generating things for you. Okay. So anyhow, we are good with this. Okay. Anybody any doubts? Okay. Okay. I think we can move ahead. Yes. Somebody was asking any doubt.
They, Dr. Madhavi has asked that do we need to install a few more libraries?
Okay. Yes, Dr. Madhvi, I have seen your question now. Dr. Madhvi, we maybe, yes, we need to install more libraries as per, as per the requirement. We may need to install the libraries on the go, but that is okay. We have to just use the command pip and we are good with installation part. So we don't need to worry about it, right? So, right? Okay. Yes. Thank you, ma'am. Thank you for the confirmation. Let's move ahead, everyone. Okay. So, these are the applications of NLP. Now, talking about the different applications of NLP, we have question answering, chatbots, we have sentiment analysis, we have spam message detections. Now, these all are, real-time applications that you can see and you can use in your systems. Spam message detection, you all see that in your Gmail accounts where, you have a different spam folder and directly it is, very, very accurately it is doing it. Sometimes it may miss a few emails because nowadays phishers are also very innovative and they innovate new messages, new type of emails to fool the people. But anyhow, it is able to detect the spams and successfully filter it out into spam folders, right? So again, NLP is used for that purpose. Also machine translation, also that means language translators. We have machine translators, spelling and grammar corrections. I am very fond of using Grammarly. Okay, Grammarly is a very, very nice tool. I hope most of you will also be using Grammarly for correcting the text, for correcting emails, because we have to write a lot of reports, we need to write a lot of emails every day. I'm writing a lot of uh, what should I say, text. So I need to correct that text. I need to correct those emails, those small articles, small blogs. So I need to correct those things. So I can't, every time I cannot put my brains into that. So Grammarly is working good for me. Okay. Similarly, Word is also working good, but Grammarly gives you new innovative or alternate text that you can use. So that is why it is one of the AI tools, not a promotional thing, but it is a good one. Okay. Anyhow, speech to text conversion and speech recognition also, and information retrieval, web searching also. So all these are different type of applications that NLP can help you out with, right? Okay. So installation we have already done, spacey and everything. Linguistic annotations we already know, just a brief thing like what we will may be using for tokens and everything. So I'll be discussing all these things as and when we are coming with those token attributes. Okay, so like dot text means the original
We
word.
have a query.
Okay, I just take
This
that, ma'am.
is
Okay. Ma'am, if you use Grammarly, then it will be added to internet contents. Will it be added to internet contents? Okay, Dr. Gayatri. See, ma'am, that actually every application is doing nowadays. It is going to, because it has to train its model also, and real time. What can be better than taking the text from the people who are using those apps, and that I don't mind this, because every application that you install today, every application, every website you use, every tool that you use has this policy that it will be added. Okay, they are going to use those words for their internal training purposes, so that is okay, they are going to be using those things, right? Okay, but as far Grammarly's use is concerned, it works very good for me, because when I'm writing down emails, because naturally when you are writing emails, or when you are writing text, or you're formatting things, then you actually fall short of words for correcting them, using synonyms, and aggregating things, or creating a better sentence out of it. Then Grammarly comes to my rescue, and I am able to create good mails. I am able to create good text from with the help of Grammarly. So that's why I was just telling you that it's good. But otherwise, the question that you have asked, that yes, it may be added to internet contents, and that is true, it may be added. I hope, ma'am, I have answered your question. That is okay. Yes, ma'am. Any, if I missed something, then you can just revert that back to me. Thank you so much. Okay, guys, any other doubts we have related to NLU and NLG? Any other doubts we are having? Okay, I think we are good with this. Okay. Yes, Sonia ma'am, if you get any more doubts, are there any further doubts, or shall we continue?
Ma'am, you can continue. Please.
Okay, thank you, ma'am. Thank you so much. Okay. Okay, we are done. Okay, fine. Coming to NLP pipeline and NLP core processes. Let us talk about the core processes of NLP, because once we are done with the core processes, the pipeline of NLP, then in the coming session, in the afternoon session, we will be able to work with the advanced applications of text to speech, speech to text, plus new text generation from an API and a website scrap part. So let us try to wind this up quickly. So NLP pipeline, it has, these 9 components. When you are creating a pipeline, when you are creating an NLP application, you have to talk about these things. Okay, you have to talk about sentence segmentation, word tokenization, stemming, lemmatization, identifying stop words, dependency parsing, pause tags, NER, and chunking. Let us talk about each of them one on one. Okay, let us talk about sentence segmentation. Okay, let me give you a brief overview, and then we are going to discuss them with examples. So sentence segmentation means that when you are giving, say, we are giving a command which is in the form of a big paragraph. Okay, you want something to be done, you want GPT model to do something, or you want Copilot to create something. So you're giving it in a paragraph format. So that paragraph, first of all, needs to be segmented and broken into small pieces. So each and every paragraph is composed of several sentences. So the first point is to segment those sentences. Okay, so you are going to segment a complete paragraph. If I talk technically, what may happen in Python, then that paragraph may be converted into a list of sentences, and further a list of sentence can be divided into a list of words. Okay, so it is going to create ultimately a matrix of words. Okay, two-dimensional matrix, where each and every row is composed of a complete sentence and columns specifying the position of the words. So you can assume it to be a two-dimensional matrix composed of words. So sentence segmentation means segmenting sentences out of a paragraph, and word tokenization here refers to dividing the sentences into words to create a list of words. So every time the breaking up is happening, at either at the paragraph level, sentence level, it is going to create a list. Okay, please understand that part. Fine. Okay. Now, coming to this part, let us see what tokenization is. First of all, let us talk about the tokenization. Tokenization is the process of breaking down text into smaller units called tokens. These tokens can be words, subwords, or characters. Tokenization is the first step of text processing. Now, as I told you, each and every paragraph is broken into sentence. So the tokenization here becomes sentence tokenization, where you are splitting it into sentences, and then sentences are split into small words, and the technical name for each word is a token. So that is where word tokenization comes into role play. So it splits text into individual words. Okay. Characters also, if you have used double quotes, single quotes, slashes, full stops, everything will be a token. Understand this part. Okay. Double quote, inverted commas, hyphen, then dots, everything that you put will come under the category or will be known as a token. The next thing is stop words. Stop words are actually those words that do not have any importance in it. Like you are just using those words for connecting things, for say joining things, or just referring to the flow of the sentence. For example, the is, in, a, all these articles and small is, in, these kind of words. These are stop words. They do not convey any important meaning to that sentence. They when I talk about the tokens, I always say दो चीजें ही आपका सिस्टम बहुत अच्छे से पहचानता है और कोशिश करता है, वो होता है नाउन और वर्ब. वो यही जानना चाहता है कि काम क्या करना है और किस दिशा में करना है. इतना जानेंगे, फिर उसके बाद धीरे धीरे सिमेंटिक एनालिसिस होता रहता है उसका. बट out of those things, apart from those things, other words, say the, in, is, a, often, all these kind of words, they are not very important, so they are removed. Okay, these are known as stop words. These are words where the system stops, halts, and removes them. Okay, so the purpose is to remove stop words so that we can focus on more meaningful words. We do not need to halt on these stop words, so these needs to be removed. Next process is stemming. ओके, स्टेमिंग मीन्स आप वर्ड को उसके बेस में लेके जाइए. ठीक है, जैसे फॉर एग्जांपल हमारे पास गुड, बेटर, बेस्ट, तीन फॉर्म्स में वी हैव वर्ड. सो गुड, बेटर, बेस्ट, ऑल ऑफ देम दे आर रिलेटेड टू अ सिंगल बेस वर्ड, और यू कैन से रूट वर्ड, दैट इज गुड. गुड का ही नेक्स्ट फॉर्म बेटर था, उसका ही नेक्स्ट फॉर्म बेस्ट था. सो द रूट वर्ड विल बी गुड. Okay, so what you are trying to do, you are trying to come to the root, come to the base word from which that particular word may be doing anything. For example, classify एक word है, suppose classify, classifier, classification, classifying. These can be different modifications of those words. So class, classify, classification, or say classify main word, classify, classification, classifier, class, ये इन सब का जो base word है, that will be classify. Okay, so sometimes it may also be reduced to class also. Class में रिड्यूस हो जाएगा, क्लास से क्लासीफाई आया, क्लासीफाई से क्लासिफिकेशन आया, क्लासिफिकेशन से क्लासीफायर आया. सो द बेस और द रूट वर्ड में बी द क्लास वर्ड. सो ये है स्टेमिंग, जिसमें आप, स्टेमिंग मींस पेड़ की स्टेम से उसकी जड़ों तक जा रहे हैं आप. मेन बात ये है. सो यू आर ट्राइंग टू रीच टू द रूट फॉर्म. सो द मेन एल्गोरिथम्स दैट वी यूज फॉर दिस इज पॉटर स्टेमर, which is as far the most efficient stemming technology and algorithm that is being used nowadays. I have, in my experience, I've always and always used Potter stemmer, and I didn't work more on snowball stemmer or Lancaster stemmer. जरूरत नहीं पड़ी मुझे. Potter stemmer is one of the most accurate ones, and your work can be easily done. Otherwise, if you need to go for other requirements, then you can work on snowball and Lancaster, right? Okay. Lemmatization. The next process is lemmatization. Lemmatization reduces words to their base or dictionary form, known as lemma also. It considers the context and converts to their meaningful base form. अब आपका जो stemming था, आप base word पे पहुंचे, आप root word पे पहुंचे, but lemma is trying to get meaning into that, कि उसके मीनिंग के हिसाब से उसको किस रूट में लेके जाना है. बिकॉज ऐसा हो सकता है, जैसे ने आपको बताया क्लास, क्लासिफायर, क्लासिफिकेशन, क्लास, इस तरीके के वर्ड्स है, तो इट मे बी रिड्यूस टू क्लास, बट लेमा विल try to understand the meaning of that class. So class may be meaning to classify. So lemma may reduce the words to classify word and not class. तो जब उसके मीनिंग को भी आप अटैच कर देते हैं, जब आप उसके मीनिंग के साथ उसको रिड्यूस करना चाहते हैं, तो अपने आप एक्यूरेसी बढ़ जाती है इसकी. तो स्टेमिंग और लेमेटाइजेशन दोनों ही वर्ड्स को रिड्यूस कर रहे हैं, उनके रूट्स तक लेके जा रहे हैं. बट लेमेटाइजेशन मीनिंग की बात करता है. इट अटैचेस अ मीनिंग टू दैट बेस फॉर्मेट. इफ द मीनिंग इज करेक्ट, then lemma is going to work wonders. Otherwise, stemming is going to create only the root, the shortest or the base word for that particular series of words. Okay, so lemma ka yahi difference hai stemming se, that it attaches a meaning to that root or the base word. Okay, before we actually come ahead, let us just try to do small implementations till lemmatization. Then we are going to create bag of words. Nahi to bahut zyada theoretical ho jayega. Let us come back to this. Okay, so now it's time for action again. Please, everybody come back to your Jupyter notebook either or on Google Colab, whatever you are using, right? Okay, so now we are coming to tokenization. Let us first of all talk about tokenization, जिसमें हम पूरे sentences को words में convert करने की कोशिश कर रहे थे. So I have here sentences. I am trying to convert them into sentence tokens also, into word tokens also. Just see to this. So for this, now I am importing NLTK. So I have used Spacy also. I have shown you the use of Spacy in NLU and LG. Now I am using the next library, that is NLTK. Okay. As of now, NLTK comes purely pre-installed with Jupyter Notebook also and with Google Colab also. So I don't think you are going to face any trouble in it. You can directly import it. Import NLTK. NLTK dot download Punkit. Now, what is Punkit? Punkit is a tokenizer class. Punkit actually डिवीजन में जो क्लास का रोल है, जो एक मॉडल है, जो प्री ट्रेन मॉडल है अगेन एनएलटीके का, जो टोकन्स को पहचानता है, उनसे वर्ड्स बनाने की कोशिश करता है. So the collection it tries to create from that particular input text that you have given. So the class that works is Punkit. So you need to download Punkit, right? So you are downloading Punkit from nlt.tokenize. Now you are going to use the tokenize class, nltk.tokenize import. We need to import two particular classes. First is the word tokenize class. Second is the sentence tokenize class, which is given by sent_tokenize. So word tokenize class deals with tokenizing or splitting the sentences into words, and sent tokenize class is concerned with splitting the paragraph into various sentences. Okay, so suppose the input text that I am giving is natural language processing is fascinating. It is implemented in R and Python, both languages. So these are the two sentences that I have given, right? Now, tokens. I'm going to create first of all word tokens out of the entire paragraph. So you can see tokens equals to word tokenized text print token. So now I am using the word tokenized class to convert this entire text into a sequence of words only. The word simple tokens only. So I can do that through word tokenized class, and I print these tokens. So I'm going to get this natural language processing. You can see each and every word you can see here. Natural language processing is also there, because we have not yet removed any stop word, right? So is there, fascinating is there, exclamation sign, it is implemented. So each and every word is now converted into a token, into a simple string of words, or you can say a list of words. So as I told you, every time you divide something, it is going to create a list. Okay, so this is a list of words that is being created over here. Next, if we try to work with sentence tokens, now we need to divide this entire paragraph what we have given into sentences. So we can use sent tokenize, and we are going to divide this text into sentences. So now if you print these sent tokens, you are going to see two sent tokens. The first is this natural language processing is fascinating. Okay, it has recognized that this is the first sentence, even though I actually forgot to put a full stop over here, but it recognized it with the help of this exclamation sign. And secondly, the first letter of this particular sentence is beginning with a capital letter. So see the smartness of the system. It has tried to associate these things and created it. It is not dependent on full stop only. It is trying to recognize from other symbols also, right? So it has tried to recognize this is the first sentence, and sentence token, this is the second sentence. So you can see this is a list of sentences that is being created. Okay, so now I'm just going to give you this code also. You can try working with this code also, and you can try to implement this and let me know if you are able to do this or okay. So I have given you this particular code also in the chat box. You can just take that code and try to do this. Just give me a check once you are done. Are you able to do this? Working fine? Okay. Thank you, Dr. Madhvi. Thank you so much for the confirmation. Rest of you guys, are you facing any trouble into it or are you done with this? Done. Okay. Thank you, Sonia ma'am. Thank you for the confirmation. Okay. I hope guys, all of you are also working on this and you're not facing any trouble. Okay. So we are good with tokenization part. Now coming to the next thing where we wanted to remove stop words, because you can see here we have a lot of stop words. We have is, we have it, we have, again, in, and all these words. We don't need these words. These are, insignificant words. So the next step was to remove stop words. Okay. So how we can do that? Now we need to use NLTK library only. And from it, we have to use this corpus class. Just see to this. So nltk.corpus imports stop words. So we are using NLTK library and its sub-library corpus, and from that we are importing this class stop words. Okay. Now nltk.download stop words. Now this is what this stop words is. Again, stop words is a class. I'm just writing a comment for you. Stop words is a class of general list of stop words. So in English, whatever general list of stop words you have, this class contains all those stop words. So it is going to match your text with the list of stop words, and wherever it is finding a match, it will be removing that particular word from the the tokens, from the list of tokens that you created. Okay. So now just see to this what we are doing. We have already downloaded nltk.download stop words. Stop words equals to set stop words dot words English. So we are just setting it that okay, we are going to work with English language, and you need to take all the stop words in English language, match with this particular language only, right? So stop words equals to set stop words dot words in English language. Filter tokens. Now we are creating a filter token, and we are using a list comprehension technique. Okay, so this is a list comprehension technique where inside that list we are creating a filter by removing the stop words. Just see the very important list comprehension that we are creating here. Word for word in tokens. Okay, so word for loop. Here you can see the for loop, okay, working in action, and this is the output. Okay, word. Okay, word for word in tokens if word dot lower, not in stop words. Now understand this list comprehension, what it is trying to convey, that it is going to run this particular for loop for each and every word in the token, right? It is running this for loop for each and every word in the token. And inside that for loop, it is checking if word dot lower, after converting every word, whatever that input text had, that token must be converted into lowercase. So it is just converting each and every word into lowercase and checking in the stop words library, which is set in the English language. So it is trying to convert it into lowercase and then checking in the stop words list. Okay. So if the word is not in stop words, then this word must be returned. So this word, the first thing that we put in the list comprehension is the output. So we will be having this word as the output. If we run this particular for loop in which we are checking each and every word in the tokens list, the tokens list was here. Okay, we have this tokens word tokens list. Okay, so this we have already created above. So tokens equals to word tokenized. So that particular list of tokens was created. Now we are using those tokens only. So we are implementing the for loop in this token list. So for word in tokens, if word dot lower, after putting each and every word in lowercase, we are checking if it is not in this stop words list, if it is not in the stop words list, then this word, the output, the word must be returned. So the word will become the output. The word means each and every token will be checked, and if it is not present in that stop words list, then it will be returned to the filtered tokens list. So this filtered tokens will be creating again a list. Okay. Now, if you print filtered tokens, so now if you are printing this, what you're going to get, you're going to get, you know, all the words except is, in, be, a, are, and all those stop words are removed, right? So you're going to get natural language processing, fascinating. You're going to get the symbol also. Symbol is not considered to be a stop word. So implemented are, again, it's not considered to be a stop word. Python languages is also not considered to be a stop word. I hope that makes sense for everybody. Okay, you are able to understand each and every code that we are using. So I'm just putting this code also, you know, for your help. Okay, Ramita ma'am was asking something. Ramita ma'am is saying, what is Pankti? Pankti is a class, ma'am. That is a class which is used to create a model of words. अगर आप इसको देखेंगे NLTK में जो Pankti class होती है, ये actually वर्ड्स का कलेक्ट करने में, वर्ड्स का टोकनाइजेशन बनाने में हेल्प करती है. अगर आप पंकिट यूज करते हैं तो पंकिट से आपके जितने भी कंप्लीट सेंटेंस था, दैट वर्ड्स व्हेन दे आर स्प्लिटेड, सो कलेक्टिंग देम, the task of collecting and creating a list of words is being done by Pankit. Okay, so that is why we are using that particular thing. ये बैकग्राउंड में यूज होता है. अगर आप ये सोचेंगे कि इसको हम कहाँ पे यूज करें, क्या करें, तो आप ये देखिए कि ये पंकिट जब डाउनलोड हो जाता है तो ये NLT के डेटा में ही जाता है. तो ये जस्ट अपडेट करने के लिए होता है ताकि टोकनाइजेशन मॉडलिंग इजी हो जाए. मैं इस पंक्ति को अलग से यूज नहीं कर रही हूँ, बस पंक्ति क्लास is downloaded just to update your NLTK so that it can create a better corpus out of that, the better corpus out of that words. Okay, so that just for updating that part we are downloading Pankti always, क्योंकि हर बार कुछ ना कुछ updates होती हैं, लिस्ट में words add हो जाते हैं, कितनी कितनी चीजें updates में आती हैं. So just to keep it up to date we need to download Pankti, right? I hope that makes sense, ma'am, right? Okay, just give me a check, everybody. The stop word part is done. Okay, are you able to do it? Okay, thank you for the check, ma'am. Yes, okay, thank you, Dr. Madhvi, thank you for the check. Rest of you guys, are you able to work on it? Yes, okay, thank you, Sonia ma'am, thank you. Anybody else who is facing any issues in it? Okay, fine, I think we can move ahead. Great. So we are done with tokenization, we are done with the removal of stop words. Let us move ahead. Now we were talking about two things. One was stemming, one was lemmatization. Let us talk about those two things. Now stemming reduces words to their root form without meaning. यहाँ पे meaning का कोई लेना देना नहीं होता. Directly, meaninglessly, that complete series of words just converted to their root formats without understanding the meaning. So I am, as per my favorite, we are using the Potter stemmer. Okay, so from nltk.stem, now the stem module, we have the stem submodule in NLTK library. So we are using nltk.stem submodule, and from here we are importing Potter stemmer class. Okay, now Potter stemmer class will help you to stem and convert your words, your tokens into their root form. कैसे? देखिए, we are creating an object, stemmer object, through using the Potter stemmer class. We have used this Potter stemmer class, इसका constructor call किया हमने, and we have created an object out of it. This is the stemmer object that is created. Now this is the stems. Stems are the list that we are creating. Okay, so list again, देखिए मैं यहाँ पे फिर से हम list comprehension का use कर रहे हैं बहुत अच्छे से. कैसे कर रहे हैं देखिए ध्यान से. So stemmer dot stem word. Now this is going to be your output. जैसे मैं बार बार बोलती हूँ, जो आप return करते हैं वो सबसे यहाँ पे आता है, last में आता है. So stemmer dot stem word, this object will be applied on each and every word. Okay, जो return हो रहा है. कब? जब आप for loop लगा देते हैं. So for word in filtered tokens, so for each and every word in filtered tokens was here the list of filtered tokens after you had removed all the stop words. It created this filtered token list. So now what we are trying to do, we are trying to implement the stemmer object. We are trying to apply this stemmer object on each and every word which we are going to retrieve from the filtered tokens list. Okay, so stemmer dot stem word, this will be the result for each and every word in filter tokens. So that will be stemmed. Okay, आप यहाँ पे स्टेम मेथड का यूज कर रहे हैं, वर्ड एक हर वर्ड का स्टेम क्रिएट कर रहे हैं. This stem method is present inside the stemmer class, so it is called with the help of stemmer object. So stemmer.stem word for each word in filter tokens. So now the stems will contain a list of all the stemmed tokens. Each and every word stem is being created, so it is being stored in the stems list. So if you print this stems list, you are going to get this. Just see to this. आप देखिएगा यहाँ पे कोई भी मीनिंग से कोई लेना देना नहीं है, बिल्कुल शॉर्टेस्ट लोएस्ट बेस में जो कन्वर्ट कर सकता था क्लास को, किसी भी वर्ड को वो कर रहा है. जैसे मैंने आपको एग्जांपल दिया था, क्लासिफायर, क्लासिफिकेशन, क्लासिफाइंग, you give all these words, it will always reduced in stem to class without understanding the meaning that you are trying to classify. You are trying to give a bifurcation, division or something. The meaning is not attached. So you see over here, the, you know, just understand from my screen, this was the natural, this was the word natural. It has been stemmed to nature without, you know, meaning. Next, language, again it is being converted to language, so last e is also reduced. Okay, the little meaning is attached, no meaning is attached over here, little or no meaning. So processing reduced to process, fascinating reduced to fasten. Then you have this exclamation sign coming, implemented, you know, it is being shortened to implement. R. Okay, now see this is very important that I wanted to show to you, that you know, when you have a simple caps letter, okay, say R programming language, now it has tried to reduce it to small case. So you can say small case or small caps is the reduced form of the uppercase language, that was R language. So just you know, that word has been reduced to small caps just to show the shortening. Now Python, again the capital was removed and you can see Python. Then you have languages, it is you know, shortened to language without e. Okay, so the last e is always removed. Fine. So this is how you are trying to stem things. Now I don't think you can find any meaning attached to these forms. Okay, so this is how stemming reduces. Okay, so I'm just putting this code for your reference in the chat box. You can directly do that. Okay, I've just put the code in the chat box. Just check if you are able to do this. Give me a quick check. Are you done with this? Are we good? Okay. Yes. Are we done with this, guys? Everybody? Or you are facing any trouble in this? Okay. Thank you, Ramita ma'am, for a check. Rest of you guys done. Sonia ma'am, thank you so much. Working? Okay. Thank you, Dr. Madhvi. Thank you so much. Okay, so I hope these codes are working good for you and you are going to get good results out of them, right? Okay, now coming to lemmatization, just understand the difference and see the difference also what they are doing. So lemmatization, here we are going to download WordNet. Okay, so if here you see here in stemming, we are not using any online dictionary, we are not using any updated model, okay, of words. We are directly trying to, you know, cut the words into smaller or the root formats. Okay, but lemmatization is different. It attaches a meaning. So meaning can only be attached when you have a good collection of words that your machine can train on, that your model can see, right? So here for doing lemmatization, we need to download WordNet. Okay, so see here from nltk.stem, again we are using that same stem submodule. So nltk.stem import WordNet lemmatizer. So the class that we are using for lemmatization is WordNet lemmatizer, and we are updating this WordNet lemmatizer with WordNet model. So if you ask me what is a WordNet model, then I will say WordNet is a model for creating reduced or base words. Okay, so it is a with meaning. So it has meanings attached to it. So this is a complete word network library, or you can say word network, which will, you know, create meaningful words for you, reduced yet meaningful words for you. Okay, so it is going to create that way. So lematizer equals to word net lematizer. So we have now used this class word net lematizer. This class constructor is being called and we are creating an object out of it. So lematizer is an object that we are creating, and similarly as we created stems above, we are here creating lemmas. Okay, so lemmas equals to lematizer dot lematize word. So here we were using, see, the the simple or similar syntax is being used. There we were using stemmer dot stem word. Here we are using lematizer dot lematize word, and the list comprehension is same for word in filtered tokens. So we are using all the words in filtered tokens. It is attaching a meaning to it, and then it is giving you lemmas. Okay, so the list of lemmas. Now see, this nature had no meaning, but now natural cannot be further reduced because it is something meaningful. So natural stays as it is, language stays as it is, processing, fascinating, implemented, R, Python, languages is being converted to language. So you can see a few changes, but the meanings are attached to things, and in the same way you can just see R is as it is because it is attaching a meaning that R is something, some noun, some basic name of a particular language. Similarly, Python, P is capital. So it is giving you a meaningful word reduction or taking it to base words, but only then when some meaning is attached to it. Otherwise, it is keeping that thing intact. Okay, so I hope that makes sense for everybody. So I'm just giving you this particular code. You can just check that out. Okay, Dr. Gayatri has also given a check. Okay, thank you so much, ma'am, for the check. Your code was working. I have given you this lemmatization code also, so you can just check the lemma part. Fine. I hope that makes sense for everybody and you're able to run this. Okay. Okay, Sonia ma'am, like since it is 12 noon, like do we need to take a break right now?
Yes, ma'am.
Okay.
We can take a break for 1 hour.
Okay.
We'll resume back after 1 hour.
Not an issue. We'll be catching up in 1 hour and we'll be starting from, we'll be creating word to vector and bag of words. These are two most important things that I need to complete. And after that, we will create application of speech to text and web scrapping and the text generation. We'll be creating two projects. Okay. So Sonia ma'am, shall we stop here?
Okay, ma'am.
Okay.
Thank you so much, everyone. Thank you, ma'am.
Thank you, ma'am. Thank you so much.
We will resume back after 1 hour with another informative session by Miss Nidhi Grover. So let's meet after 1 hour. Thank you so much.